Hi everyone, in today's lesson we're going to talk about how to find limits algebraically. So what we're going to do is we're going to use something called direct substitution. So it means the function is continuous and it has no holes or asymptotes at that value when you get a whole number, a fraction, or a decimal. So how to solve these? We're going to plug the value directly into the function and the result is your answer. So let's just first look at it graphically. So say I have the limit as x approaches pi of sine of 2x. So here's the graph of sine of 2x, and as x approaches pi, which is right here, from the left and from the right, it looks like the limit is 0. So I want to prove that algebraically. So we know the answer is 0 just by looking at the graph, right? Because it approaches 0 from both sides. How would we do this algebraically? We say the limit as x approaches pi of sine of 2x. What we're going to do is we're going to plug in for x. So in this x, we're going to put a pi. So we have sine of 2 pi. So you want to ask yourself, what is the value of sine of 2 pi? So if you remember correctly, if we have a unit circle, here's the value 1, 0. 1, 0, and remember that sine is always the y value. So sine of 2 pi, or 360 degrees, would be right here. So we know that sine of 2 pi is 0. Okay, now let's look at the second example. If I want to find the limit as x approaches 3 of this negative quadratic, well, we can tell just by looking at the graph, here's where 3 is. So the limit from the left and the limit from the right kind of looks like it's going to approach negative 2. So limit from the right, limit from the left looks like I'm approaching negative 2. So if we were to do this limit graphically, we know the answer would be negative 2. So let's do it algebraically. So it's the limit as x approaches 3 of negative 2x squared plus 16x minus 32. So what we're going to do is we're going to plug in 3 directly into the x values. Now take a minute, pause the video, and type this all into the calculator and see if you get negative 2, and then hit resume when you're ready. Okay, you definitely should have gotten negative 2. So that shows me that my limit is negative 2. All right, let's look at example number 3. So I want to find the limit as x approaches negative 4. So here's negative 4, and from the right and from the left, it looks as though my y value is somewhere over here, and it's a little bit less than 1. So I can't tell from the graph, so let's find out exactly what it is. So I'm going to do it algebraically. I want to find the limit as x approaches negative 4 of x plus 7 over x squared plus 16x plus 63. So what we're going to do is we're going to type in negative 4 for all x values. So negative 4 plus 7, negative 4 squared, plus 16 times negative 4 plus 63. So take a minute, type this into the calculator, and reduce it into a smallest fraction, and then hit resume when you're ready. Okay, your answer should be approximately 1/5. So our limit as x approaches negative 4 should give us 1/5. All right, now let's look at the last example. We want to find the limit as x approaches 3 of this negative square root graph. Well, from the graph itself, we could see that the limit from the left and the limit from the right is going to be approximately a little bit less than negative 2. So let's see if we can do this algebraically and find out exactly what that value is. So we want to find the limit as x approaches 3 of this square root function. So I'm going to plug in 3 for x, and I have negative square root of 5 as my answer. And if you type in negative square root of 5 in the calculator, you get approximately negative 2.23, so on and so on. So that's what we thought it was. It was a little bit less than 2. So this limit is equal to the negative square root of 5. Okay, let's move on to the next page. Okay, so now we have a direct substitution, but you get 0 over 0. What that means is that the function will have a hole at that value. So let's just see what happens. So I want to find the limit as x approaches negative 4. So we know if we look at the graph, the limit from the left and the limit from the right both are approaching the y value of negative 3. So let's just see what would happen if we were to do this algebraically. So we're going to plug in negative 4 squared plus 5 negative 4 plus 4 all over negative 4 plus 4. So it looks as though the denominator is 0 because negative 4 plus 4 is 0. Now what I'd like you to do is type all this into the calculator and then hit resume when you're ready. Okay, I got 0. So 0 over 0 does not give us the value that it should be. It looks like the limit is negative 3. So when this happens, when you get 0 over 0 after you directly substitute, you want to factor and see if you can cancel anything out. So we have this trinomial here that we could factor. So we want to find the factors that add to 5 that multiplied 4. So those factors are x plus 4 and x plus 1 all over x plus 4. So see how the x plus 4's cancel? So we can simplify this and then take the limit again. So the limit as x approaches negative 4 of x plus 1. So now we're going to substitute our negative 4 into here and see what happens. So we have negative 4 plus 1, which equals negative 3. So you see how that's my limit now? Now I got negative 3. So the answer to this question is negative 3. So just to recap, the first step is to plug in. So since we got 0 over 0, that's not okay. So 0 over 0, sad face, that's not okay. So our second step was to factor. So we factored and we canceled. And then our third step is to plug the negative 4 into the simplified version. And then that becomes our limit. Okay, let's try one more example. So again, we want to find the limit as x approaches 4 of this fraction. And as you can tell from the graph, as x approaches 4 from both directions, it looks like there's a hole in the graph, but it looks as though the limit is going to be somewhere below 1. I'm going to assume a half, so let's just see. So question mark, is it a half? Let's find out. So we want to do our first step, which is plug in. So we're going to plug in 4 and see what happens. So 4 minus 4 over 4 squared minus 6 times 4 plus 8. I know the numerator is 0. Let's just double check what happens in the denominator. So take a minute, throw this into your calculator, and then hit resume for the answer. Okay, you got 0. So 0 over 0 is no good. So my second step is going to be to try to factor and simplify. So the x minus 4 can stay, and we're going to factor that denominator. So what numbers add to negative 6 that multiply to 8? And that answer is x minus 4, x minus 2. Looks like those will cancel, so I will be left with 1 over x minus 2. So now I want to take the limit as x approaches 4 of my new simplified version. So the second step was factor and simplify. And my third step is now plug the 4 into the simplified version. So the simplified expression. And let's see what happens. So we're going to plug that 4 into the simplified expression. So we have 1 over 4 minus 2. And 4 minus 2 is 2, so 1/2. And that's what we thought it was. So this limit is equal to a half. All right, so just to recap, what we're talking about here is that we're always going to try direct substitution. So directly plug your number in and see what happens. If you get 0 over 0, then you'll have to factor and cancel out, and then plug your number back into that simplified equation, and you will always get the limit that you need. All right, jot down any questions that you have, and then come in with class questions tomorrow. All right, have a good night.